Welcome back. We're still going to solve quadratic equations using quadratic formula. This time I'm going to show you that not all your solutions are going to be rational numbers. Sometimes your solutions are going to be irrational numbers. Now you have to know your vocabulary. Irrational means your number cannot be written as a fraction. And the kinds of numbers that we cannot change to fractions are examples of square roots that we cannot do in our head. For example, a square root of 2, we cannot perform that operation. That's an irrational number. A square root of 3, we cannot perform in our head. That's an irrational number. If you typed a square root of 2 or a square root of 3 in a calculator, the calculator would spit out a decimal that's this long. It's non-repeating, there's no pattern to it, and it doesn't end. Your most famous irrational number that you've learned in math from elementary school is pi. You all know when you see the pi symbol, it stands for approximately 3.14. But really, pi is a decimal that goes on forever with no pattern. So that's the kind of number that we call irrational. Okay, let's look at our quadratic equation. We've seen this one before. X squared minus 8x minus 11 equals 0. And we've already discussed that this quadratic equation cannot be factored. You cannot have two factors that multiply to 11 and subtract to 8. We also know we cannot use the square root method to solve this quadratic equation because of that middle term, 8x. So we have no option. We have to solve this quadratic equation using the formula. Again, it's already written in descending order. It's already set equal to 0. So I just need my three values. A is always in front of x squared. It's understood to be 1. B is in front of x. It's negative 8. C is your constant. It's negative 11. So now I'm going to rewrite my formula with these values. So x equals negative b is your additive inverse, your opposite of b, so you would put positive 8. Plus or minus square root. Then we're going to do b squared. So we have negative 8 squared minus 4 times a, which is 1, times c, that's negative 11. All over 2 times a, which is 1. Now we know to work inside the root. So the first thing we're going to do inside the square root is square negative 8. Negative 8 times negative 8 is positive 64. Then we're going to multiply negative 4 times 1, which is negative 4, and then multiply that to negative 11. And a negative times a negative makes a positive, and 4 times 11 makes positive 44. We still have two numbers inside the square root, so now we're going to add them up. And 64 plus 44 is 108. So now our equation is x equals 8 plus or minus square root 108 divided by 2 times 1. And now we got to have to do the square root. Well, everybody look closely. We all know 108 is not a perfect square. But you can't leave that answer because you have to reduce it. So now we're going back to our modules 15 and 14, 13. How do you reduce a square root? You find the largest perfect square in 108, which happens to be 36. So I can rewrite the square root of 108 as 36 times 3. And I know the square root of 36 is 6, so the 6 comes out of the square root symbol, but I cannot do the square root of 3, so it stays inside. So now we have x equals 8 plus or minus 6 square root 3 divided by 2 times 1. Now we have to break it up into two expressions. You can't add and subtract at the same time. So really what we have here are two solutions. We have x equals 8 plus 6 square roots of 3 over 2. X equals 8 minus 6 square roots of 3 over 2. Once we break this quadratic formula up into two parts, now all we got to do is put together what's in the numerator and then divide. But here's our new problem. You can only add and subtract terms that are alike. Can we physically add an 8 to a 6 square roots of 3? Absolutely not. That does not say 8 plus 6. It says 8 plus 6 square roots of 3, and you cannot add a whole number to a radical. So we can't work the numerator. We have to leave the numerator as 8 plus 6 square root of 3 8 minus 6 square root of 3. But we still have another operation to do, division. It says divide by 2. Now here's where the boo-boo is going to be. Most of you are going to say, I'll divide 8 by 2. It doesn't say to just divide 8 by 2. It says to divide all the terms in the numerator by 2. So ladies and gentlemen, either they both divide by 2 or you leave it alone. Well, 8 does divide by 2. That's 4. 6 square roots of 3 does divide by 2, because 6 divided by 2 is 3 square roots of 3. So because both terms in the numerator divide by 2, we will divide. And that will give us 4 plus 3 square roots of 3, and x equals 4 minus 3 square roots of 3. You have two solutions. They are different solutions. They're actually conjugates of each other. So here's our thing. We're going to describe them. You have two answers. Believe it or not, those are real numbers. Now I know what you're saying. Miss Black, I've never seen those on the number line. Yes, I know that. But if you go on your calculator and figure out what the square root of 3 is, it's a decimal. It's roughly $1.70. And if you take that decimal, multiply it to 3, and then add the 4, you're going to get another decimal. So irrational numbers are decimal numbers. They just don't terminate. They go on forever. And that's how we have to describe this. We have two real answers that are irrational. When you're solving a quadratic equation and you get square roots in your solution, it means you have irrational numbers. That tells me and you we could have never factored that equation to solve it. Okay? Let's go to the whiteboard.